Assalamu alaikum, I am your teacher Rehan Tareen and I am back here with a new lecture of Physics Class 9. Chapter is 2 and topic is 2.4 this time. Terms associated with motion. So first of all, we have three terms which are associated with the term motion. Number 1 is position, number 2 is distance, and number 3 is displacement. First of all, I'll be telling you that what is position. Position is the exact location of anything with respect to a reference point. Now, what is a reference point and what does this line mean that with respect to a reference point? So this will be as like, if we say that what is the position of your school, you will be giving us the name of the road, that it is on this road. If you don't know the exact location of that school, you may be saying that it's on the XYZ road. So it will be with a reference point. Now a reference point can be, you can say, a popular place near to your school can be its reference point. So with respect to a reference point is said to be position of something. If someone asks you that where are the keys of the car, so you'll be saying on the table. Table is the reference point and the keys are on the table, so the position of the keys is on the table. Table will be the reference point. So this is the position. You can say simply the exact location of anything with respect to a reference point or a popular place. I will be giving you another example of position. For example, if you say that where is the Leaders Odyssey School, so I will be telling you that Leaders Odyssey School is opposite to the police line Quetta. So opposite to the police line is a famous place, it's a popular place. So I'll be saying, if someone does not know the position of Leaders Odyssey School, I'll be saying that it's opposite to the police line Quetta. So our next term is distance. I'll be telling you that what does actually distance mean. Distance is a length of a path between 2 points. It simply means that it is, if I have 2 points here, so it is the length between these 2 points. It may be straight, it may be like this, zigzag. Now, actually, what is the difference between these two terms, distance and displacement? Both are used to show length. Here I am saying that the shortest distance between 2 points, which has magnitude and direction. If we just ignore this line which has magnitude and direction and we focus on the before definition, which is shortest distance between 2 points and length of path between 2 points. Both actually are similar. Now what is the difference between both of them here? If for example this is Quetta and this is Karachi, we are going from Quetta to Karachi. Now here I'll be explaining it to you the distance and displacement very easily. If we go from Quetta to Mastoom, then to Khuzdar, then to Kalat, and then Hub, and then you reach Karachi. So you have distance points. You have traveled point to point. First you have went to Mastoom, then you have went to Khuzdar, then Kalat, then you have went to Hub. So this will be the point to point travel when you travel not exactly the straight line. And now one will be when you go to the Quetta airport and by plane you straightly arrive to Karachi. One is point to point, which is a long length, and one is straight from Quetta to Karachi. This will be displacement. Now when you move point to point, so this will be distance, and when you move directly from Quetta to Karachi, so this will be the displacement. Here I said the length between 2 points, length may be short or small, anything. But here it is mentioned in the definition that the shortest distance, shortest is the one from which you are going from directly from Quetta to Karachi, so this is the shortest distance. And the long one is when you are going by the route of the roads, and one is when you are going by the air. It's a very common example. You can see that when people go by car, so it takes almost 7 to 8 hours to reach from Quetta to Karachi. And when they go by plane, so it just takes 30 to 40 minutes when they travel from Quetta to Karachi. So this is the most common example, easiest example to describe the term distance and displacement. Now, as I have described you the distance, hopefully you may have understood it. Now we'll be coming to the rest definition of displacement, which says that shortest distance between 2 points which has magnitude and direction. So here in distance we said that it's a path. Path may be curve, path may be straight, so anything can happen in distance. But in displacement we said the shortest distance. So we'll be having, or we'll be using a direction for the shortest distance. We cannot say the shortest distance by anything else. For example, if these are 2 points and I want to go from here to here, so I'll be saying that I'm going from this position to this position. So I'll be showing you the direction, that on which direction am I moving. Or if I go from distance, so there will be no other route, so it's exactly that I will be covering the distance, the length. But when you cover a length, you are given its direction, that you are going in this direction, so then it's known as displacement. Here, one thing you may have seen in the ships when they are moving, so they are moving in displacement, a straight path to reach that point in seas. So there they use a navigation compass which has north, south, east, west marked on it. So that is actually displacement with magnitude and direction. There by the compass we see the direction and we move in a straight path, a displacement from one point to another point. This is said to be displacement. And magnitude. In distance, it's common thing will be having a magnitude because it's a quantity. So a quantity has its magnitude and a unit. So here we'll be having a magnitude and direction. In before this lecture in 2.3 we studied about scalar and vectors. So there I told you about two things. Scalar did not have magnitude and direction both. It only had the term magnitude. But vector had the term both magnitude and direction. So this magnitude and direction, this term will be a vector term. So displacement will be a vector quantity. It's not a scalar quantity. Distance will be a scalar quantity. Distance is a scalar quantity and displacement is a vector quantity. Distance is represented by S and displacement is represented by D. This was our topic of the position, distance and displacement terms associated. 2.4 terms associated with motion. So today we'll be studying two more terms which are speed and velocity. So the term speed, you may have heard this word many times in your daily life. The speed of cars, speed of airplanes, speed of cycles, speed of handwriting, almost the speed of running of human beings. This word speed is most commonly used in our daily life or daily routines, except this word velocity, speed. So first of all, we'll be studying that what is speed, what is the definition of speed, what is the formula, unit and the description of speed. So speed, when distance is covered in time taken, the body is said to possess speed. Distance covered in time taken. Now what does this statement means? Before this, in terms associated with motion, we studied about distance and displacement. Distance was the path between 2 points. You can say the longest path between 2 points. And displacement was the shortest distance between 2 points. So the longest almost means the actual path or the shortest path between 2 points. Actually the difference was like this, that if these are 2 points and this is the pathway, the road or something else of these two paths. Here you arrive the point. Now this is a road from point A to B when you have to come by walk or by cycle or by a car. So first of all you will be going by the road and you will be covering the path. You will not be going straightly from point A to B. You will be going in the paths as directed by the path. This was distance when you follow the pathway. Now if you don't follow the pathway and you directly come from point A to point B, you can say you reached point A to point B by airplane or by flying. So by helicopter from point A to B directly, the shortest distance is said to be displacement, and when you follow the actual pathway, so this is said to be the distance. So in speed, the word distance is used means we are following the actual pathway. Mostly in our daily lives, in cars, we see that what is the speed of car? It is 80, 60, 120, 100. So that is when we are covering distance in time taken. When we are moving in a car, so we are also covering distance, means we have covered a 1 kilometer distance. If you are going from Quetta to Karachi, it's almost 700 kilometers. So you are covering 700 kilometers a distance to reach from Quetta to Karachi. So this is a distance. And now when you are covering that distance, almost when you go from Quetta to Karachi, it is almost 700 kilometers and it takes a 7 hours or a 6 hours time period. So you cover that distance in time taken. So here the word is used, distance covered in time taken. When these both terms are associated together, so the term speed is formed, and speed means when you cover distance and you take time. So then a body is possessing speed. Now what is the formula of speed? Formula of speed is V is equal to S upon T. S represents here the distance and T represents the time. And V, the italic V, is the symbol for speed. These are the symbols V, S and T. So what is the formula? Formula says that when you cover distance, V, speed is equal to, when you cover distance, S, distance is represented by S, and you also take time, so S upon T, V is equal to S upon T, then speed is found. So this is the formula of speed, and now we'll be coming. Now if in numerical problems in the end of the chapter, you'll be given to find out the distance of something or the time taken by something. So if you rearrange the same formula, it will be like T is getting divided here. On the other side of division, it will get multiplied. So S is equal to Vt. This will be the formula for distance. And if you are finding out the formula for time, so it will be that T is getting divided here, so it will go on the other side of the equals, it will get multiplied, and V here is multiplying, so the other side it will get divided, so it will be S upon V. You will be getting the value of the V. You will be getting the value of the time period. Now if we want to find out the unit of the speed, so it will be using the formula and will be using the specific units of each quantity we have used. Now here in formula we have used the quantity of distance and time. So you know that the unit of distance is meters and the unit of time is seconds. It is for distance and it is for time. So we'll be saying that V is equal to M upon S. V is equal to M upon S. Here, as I've mentioned it, the unit is V is equal to M upon S. S is being divided here, so if we shift it on the upper side, it will be having a multiply by 10 raised to power minus 1 ratio, which we can also write like this, that M upon S is equal to ms minus 1. This is the unit of speed. Now, if we come, we should leave this topic uniform speed once. We'll be coming to the topic velocity first. Now, what does velocity means? Velocity is the term which is very closely related to the speed, or else we can say that it is almost like speed. But the difference here is that speed is a scalar quantity, as it does not require any kind of direction. I said that we are covering distance, so in distance I said that we are following the pathway. When we are following the pathway, so we have a specific pathway and we cannot converge or diverge from that pathway. We will be going in the same pathway. So then it is said to be distance. Distance was a scalar quantity. We are not being guided by anything. But when I have told you before in the representation of vector quantities that when you see an arrowhead representing something, so then it will be a vector quantity. In displacement, it is vector quantity. In distance, there was no arrowhead and no representation of any vector, so it was a scalar quantity. In which we have both scalar quantities, the other quantity will also be a scalar quantity. But when we will have any vector quantity including in the formula of anything, then it will be said to be the vector quantity. Furthermore, I will be explaining it to you. Now, in velocity, the definition is displacement covered in time taken. Displacement was the shortest distance between 2 points, or graphically represented by an arrowhead. So in velocity, when displacement is covered in time taken, then velocity, a body is said to possess velocity then. How does it happen? I'll be giving you an easy example. For example, if you sit in an airplane, you start a journey from point A to point B. Further, I'll be explaining to you that our cars don't possess speed, they actually possess velocity. When I'll teach you acceleration, then we'll also be learning that how do our cars possess velocity, not speed. So here I will not be explaining that, I will be only explaining to you this, that how the airplane moves from point A to point B to form displacement or to cover displacement. When airplane from point A to point B moves and it covers displacement right there, so it is covering displacement, as I told you in the formula of velocity, displacement is covered in time taken. If we are traveling by an airplane, it also takes some time, 15 minutes, 20 minutes, 30 minutes, hour or 2 hours. So it also takes time, but it covers displacement, not distance, because it goes in the shortest distance. It covers displacement. So the displacement covered in time taken by a body, then a body is said to possess velocity, not speed. Here I told you that displacement is represented by an arrowhead, so displacement will be a vector quantity. And here the speed, distance was a scalar quantity. Here both the quantities, distance and the time, they both are scalar quantities, so speed will automatically be the scalar quantity. And here in velocity we have one vector quantity which is displacement and the other quantity is time, which is scalar quantity. One vector quantity and one scalar quantity, so velocity will also be coming vector quantity because of displacement right here. The formula of velocity will be that it's represented by a bold V, or you can say a simple V with a bar or a V with an arrowhead. These will be the representations of the velocity. As before I told you the mathematical representations of velocity, the vector quantities. So velocity, as I told you, it's a vector quantity. It will be having its representation by bold letters, bar ahead with them or arrow up on them. So a bold V is equal to displacement's unit is small d. Small d is the unit, the symbol for the displacement. So a bold V is equal to displacement upon time, d upon t. Here in distance and displacement, one thing is common. The difference was just this, that one is being represented by direction and one is not represented by direction, it has its specific pathway. The common thing in both of them is that both represent length. Both quantities are being taken from the physical quantity or the base quantity length. Length's unit was meter. So here both the quantities displacement and distance will be having the same unit, which is the unit of length, and it is meter. So unit will be, instead of t, will be using the same meter, and time will be having the same unit s. Meters upon seconds is equal to, if we convert it, so s is being divided here. If we shift it on the upper side, so it will be having the ratio of multiply by 10 raised to power minus 1. Multiply by 10 raised to power minus 1 can also be written as ms minus 1. This was the unit of velocity, and I have explained you the speed and what is velocity. Now, here there are two more terms in the same topic 2.4. One is uniform speed and the other is uniform velocity. Now, what is uniform speed and uniform velocity? When equal distance is covered in equal intervals of time, then a body is said to possess uniform speed. An example will be like this, that if a body is covering 5 meters distance and it is taking almost 5 seconds to cover this distance, 5 meters distance is being covered in 5 seconds, and when this distance is covered and this time is taken, then in other 5 seconds it also covers the 5 meters distance. Means as it's going further, as it's moving forward, so it's having the same ratio of distance and time with it. If the ratio of distance here is 5 ratio 5, then it will be 10 ratio 10, then it will be 11 ratio 11. When the ratio will remain equal between the distance and time, then the object or that car or vehicle, etc., will be said to possess the uniform speed. A very easy term, when the equal distance is covered in equal intervals of time, or in simple words, when the ratio between the distance and the time remains same after time to time, then the body is said to possess uniform speed. Uniform velocity, almost the same thing, just a slight difference. There was the term speed used here, uniform speed, and here it is uniform velocity. Instead of distance, we'll be using the term displacement. All the other things are the same, that when a body covers equal displacement in equal intervals of time taken, it will be like the equal ratio between the displacement and time. Equal ratio between displacement and time, when they both are having the equal ratio, when the values are being equal after time to time, then the body will be said to have. So the next topic of topic 2.4, terms related or associated with motion. Our next topic is acceleration. First of all, I'll be telling you that what is acceleration, what is the formula, unit description, and what is how is acceleration used in our daily life. So the definition of acceleration is that the rate of change of a velocity of a body is acceleration. Now, some of the terms are used here in this definition that are rate and velocity of a body. What is rate? Rate is the word or a specific word used in the word problems or numericals for time. Rate is the same word, time. And velocity, before this acceleration, I've taught you both velocity and speed. So rate of change of velocity of a body is said to be acceleration. Now, how many types of velocities do we have, and what does this word definition actually means? The rate of change of velocity. How does velocity changes? We studied about uniform velocity, uniform speed, etc., but we did not study about change in velocity. When velocity does not remain same in equal intervals of time, then what will happen? So first of all, that in acceleration, the velocity, types of velocity, we have two types of velocity. Number one is the VI, which is initial velocity. And number two is VF, which is the final velocity. Initial velocity and final velocity. But the word initial means a starting point, a starter, and final means the ending point or the end. So what is initial velocity? Initial velocity is the velocity of a body when an object starts to move. When an object starts to change its position. That is initial velocity. Actually, this word means when an object starts. If a car has to move from this point to this point, and it starts moving from here, it is now starting to move, then that is the initial velocity of the car. Mostly the initial velocity is very less of the vehicles or automobiles. You can say the initial velocity of a bike can be of 10 kilometers per hour, and when it goes further and a point comes where it has the final velocity. Now final velocity, the word can be between a distance. Now if a body is moving and it's here, and we are only talking about this interval, so we can also take it as VF. Here it also can be VF. VF means the maximum point of velocity reached by that body at the exact ending point. Means if we are taking an interval and interval is ending up here, so it will be the VF, the velocity here will be the VF, and if it is ending here, so here will be the VF, and if it is ending as it starts here soon, so this will be the VF. VF point means, the final velocity point means the point where the interval is just about to end or is ending. So the VF is almost mostly the maximum value, which can be almost the maximum value of a car, 120 kilometers per hour. A starting point can be 10 kilometers per hour. When it starts moving, and when it is ending, its motion is ending up and it's going to be in rest again. That is the final velocity and the difference between initial velocity. So now the rate of change of velocity means when velocity changes from initial into final or final into initial, then it is said to be the change in velocity, which is acceleration. Now what is the formula of acceleration? The acceleration of formula is, first of all, the acceleration is denoted by a small a. Acceleration is a vector quantity It can also be represented by a bold A, or an arrow up it, or a bar upon it. So bold A will also always be telling us that it is a vector quantity acceleration. Acceleration is equal to Vf minus Vi upon t. In mathematics, one is a very common term that when we have to find out a positive value, so we will always be minusing the small value from the highest value. Means we will always be minusing 5 from 10, not 10 from 5. We will not be doing like this, that 5 minus 10 will be minus 5. We will be doing it 10 minus 5 is equal to plus 5. So Vf, as I told you, is always the maximum or the highest velocity, and Vi is the starting point. So it needs some time for an object to gain the maximum speed. So it will be the initial velocity is always less and the final velocity is always at its highest peak. So the highest value minus the shortest value minus the highest value, Vf minus Vi upon t, as the word rate was used to upon t. Vf minus Vi, change in velocity upon rate upon t. This is the formula of acceleration. Now if we come to the unit, so it has a specific form. It will be like A is equal to Vf upon t minus Vi upon t. Here the LCM has been taken, so it can easily be, you can see that if we separate these two terms, so it will be Vf upon t minus Vi upon t. If you take the LCM, both the denominators are the same, so both will be written as one time and it will be multiplied with each other. So we can also write it as t square, Vf minus Vi. So we mostly don't write the square with t, we write it with its unit, because in unit we mostly get it that when we find out the numerical or the magnitudic value, we add up the unit with it. So here t is repeated 2 times, so t here will be multiplied, both t multiplied, and the above values will be, denominators are the same, numerators will be having the sum plus or minus as it has. So Vf minus Vi upon t will be written as singular time. Now if I break the same value and I write the units of the Vf and Vi and t, initial velocity, final velocity, the unit for final velocity was, it is meter per second. The unit from final velocity will also be meter per second, and unit for the initial velocity will also be the meter per second. So as the units are meter per second and meter per second, so I'll be explaining it to you that how can this happen or how does this happen. If you take a value of 10 ms minus 1 and it is the final velocity Vf, and it said that find out the acceleration, so we'll be using Vf minus Vi, and the initial velocity given to us is 7 ms minus 1. So 10 minus 7, we'll be writing it as 3 ms minus 1. There is no any difference being here or which is being emerged here, so it will be as it is, as the same. And now if we come further, so it will be like as we had in this formula, Vf minus Vi, ms minus 1, ms minus 1, single will come, because here also we had two values of ms minus 1, ms minus 1, we got a single value. It may be in plus, maybe in minus, so a single value will come, ms minus 1, and down we have s minus 1, sorry s, so it will be like ms minus 1, ms minus 1, and if we converge both of them together, so it will be like ms minus 1 upon second. Then if we again change it, so it will be like the meter per second, as I've submerged it on the other side. It was like when we minus 2 of the meter per second values, we got a single meter per second value. So single meter per second value, when the s is being divided here, so if we shift it on the upper side, so it will be like the meter per second dot per second. S will get the ratio of multiply by 10 is power minus 1. Meter S, as I've told you, we've studied in mathematics that if we get a multiply sign between two of the values, so their powers will get added up or they will have a sum. It may be plus or minus. So ms minus 1 plus minus 1, it will be ms minus 1 minus 1 ms minus 2. When we get the magnitudic value of multiply between these two signs m and s, as I have mentioned it here, that when ms multiplies into s, so the powers will be added up according to mathematics, and when the powers are added up, so it will get the ms minus 2 value. So this was the unit of acceleration, formula of acceleration, definition of acceleration. Now we have a term here which is uniform acceleration. Uniform acceleration. I'll be telling you that what is uniform acceleration, how does it work, what is it used for. So the definition for uniform acceleration is that change in velocity in equal intervals or however a short interval may be. It means that when a continuous change is formed between velocity, that Vf minus Vi is having a ratio with t, and if Vf minus Vi is 5 ratio 10, then it is 10 ratio 15. It is changing with equal intervals, means 2 ratio 4, then 4 ratio 6, then 6 ratio 8. It is having an equal change in equal intervals, so then it is uniform. That type of motion will be uniform motion. So a uniform acceleration, when the rate of change of velocity, is getting a equal ratio with rate, means time. So if they are getting an equal ratio here, so then it will be uniform acceleration. Now here a specific term is used, that short interval may be. Now what does this mean? It means that when an object covers acceleration first, it possesses acceleration and it has the acceleration. For example, the sum of both Vf minus Vi is, you can say 10. If I take it as 10, the Vf minus Vi ratio is 10 and the time ratio is 20. So here it is 10 ratio 20. If it goes further, its velocity decreases, and as its velocity decreases, its time also decreases, so it will be like 5 ratio 10 then. Ratio is equal, the ratio is equal, but it is having a change in it, it's getting lower, but both the sides will be equal. If we further go in it, so it will be, if we further simplify it, so we'll be getting it back as it is. So this is uniform acceleration formula, unit, and all the definition and derivations of this topic of 2.4, which is acceleration. Now here a term is used which is the negative acceleration. Negative acceleration. Negative acceleration means that when Vf is less than Vi, means when we are getting a velocity in minus 10, minus 5. How does it happen? For example, if we have the value of Vf is 5 and Vi is 20, so 5 minus 20 will be minus 15. This minus 15 will be showing us the value of the negative acceleration. When velocity is in negative, so the acceleration will always be negative. This is our topic.